So when we're talking about derivatives of trig functions, a lot of it really just comes down to knowing the tables and the equations to use. It's everything works, like product rule, quotient rule, all the stuff works the exact same. You just have to really be familiar with kind of a lot of tables and a lot of this is the derivative for this and for that. So we won't really go over too much of that. The two basic ones that you do have to know. So if you're taking the derivative of sine of x, all right, know that that goes to cosine of x. And then likewise, the derivative of cosine of x, that goes to negative sine of x. Keep in mind that this one has that negative on there, right? So sine goes to cosine, which is still positive, but when you take the derivative of the cosine, it goes to negative sine. And personally, I don't know if there's any like cool, neat tricks that anyone has to know that it's the negative that goes from cosine to sine. If you do, maybe send me an email, because I'm always looking for kind of neat ways to memorize that, because this is an easy one to forget. So we're not going to really go over too many examples, because it really is just using a lot of these identities. So take a look at those in the book. The one kind of neat, I guess this is kind of a neat proof that we could look, and it really shows you kind of how a lot of these still follow the same rules. Is let's kind of prove the derivative of tangent of x. So if you looked in the book, you saw the derivative of tangent of x equals 1 over cosine squared of x. And so, oh, that's kind of weird. I wonder why that is. So let's take a look. All right, so the derivative of tangent, that's just, or by definition, I guess, tangent is going to be sine over cosine. Well, this is just a quotient right here, so we're taking the derivative of the quotient, so we can use the quotient rule. I'll write it over here just to help us out. So we've got f prime of g minus f of g prime all over g squared. Okay, so f is going to be sine of x, g is going to be cosine of x. So we come up here, the derivative of sine of x gives us cosine of x. So I'm going to rewrite this then as cosine of x times just regular old cosine of x minus, then we've got, all right, so then we've got just our function, which is f, so that's sine of x, times the derivative of g, so the derivative of cosine, well, that goes to negative sine. So that's negative sine of x, and then all over g squared, so that's just going to be cosine squared of x. All right, so let's simplify this a little bit. If we did this multiplication, we'd get cosine squared of x. A negative times a negative is a positive. Times sine squared of x. That's an s right there. And then all over cosine squared of x. All right. Well, if you remember from the your identities from one of your trig classes, or I believe it goes over in the book also, cosine squared of x plus sine squared of x, well, that just equals 1. So we've got 1 over cosine squared of x. And there we have it. So that's just kind of a neat little proof, neat little example. You can see that really using trig functions doesn't change any of the stuff that we've done. Really, it just comes down to really not even memorizing. We're not going to memorize these, but really having access to these trig identities when it comes to taking derivatives.